Welcome to Bidnik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask us questions, and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Basic tutors. Excellence is our word.
Alright, amazing ones. Now, welcome once again to Basic Tutors YouTube channel, a channel where we upload content you can learn from. Are you watching our video for the first time? You are highly welcome. This is Basic Tutors, yes. Now we teach mathematics, physics, and chemistry. Yes, at all levels. Thank you very much. Now, if you are watching this video and you've learned one or two things and you're yet to subscribe, you are really wrong. Please do well to subscribe right away. Thanks for watching. Now we see balancing of equation. Balancing of equation is what we're going to be treating today, and stoichiometry. Alright, balancing of equation and stoichiometry. But we're going to be starting with balancing of equation. So what do we mean by a balanced equation? A balanced equation is one which has the same number of each kind of atom. The same number of each kind of atom on the right of the equation as well as what on the left of the what equation. Alright? A balanced equation is one which has the same number of each kind of atom on the right of the equation as on the what? As on the left of the equation. Alright? So they are balanced. You get it now? When we have something like this, A plus B, when we have 2, we have A2 plus B, the reactants at the product side. Are you seeing it now? So this is what we call what? A balanced equation. Alright? We have 2A here, same with 1B here. We also have 2A here and 1B here. So this is what we call what? A balanced equation. So now, what do you mean by unbalanced equation? Unbalanced equation implies that atoms have been created or destroyed, meaning that it is therefore wrong and calculation based on it are certainly unreliable when an equation is not balanced. When the reactant side is not the same as what the product side. Okay, that is what an unbalanced equation means. E.g., we have A2 plus B giving us A plus 2B. When you look at this now, this is what we call an unbalanced equation because we have 2A here at the reactant side, and we have 2A at the reactant side, 1A at the product side. You see that it's not balanced. We have 1B at the reactant side and 2B at the product side. So this is what we call an unbalanced equation. Now I want to check out the rules for balancing equation. So let's check that out. Right, so this is what we call rules for balancing chemical equation. So the first one said equation should be balanced through the use of coefficients in front of the formulae. Equation should be balanced through the use of what? Coefficients in front of the formulae. What do we mean by that? Just like when you have, alright, so this is the coefficient of what? Sodium chloride. Okay, so this is what we call coefficients. So are you seeing it now? So equation should be balanced through the use of coefficients in front of the formulae. So this 2 now is the coefficient of this formula, sodium chloride. Do you get it now? So common gases like hydrogen, chlorine, and nitrogen, all three gases, are diatomic. E.g., H2, 2 means di. Cl2, 2 means di. N2, 2 means die. Alright, so now that's what this number 2 means. Okay, sodium like what? Common gases like what? Hydrogen, chlorine, nitrogen, oxygen. They are what? All three gases are what? Diatomic. Okay, so now 3 said elements such as sodium, potassium, copper, and iron in the free state are represented by their atomic symbols. Alright, sodium, potassium, copper, and iron in the free state are represented by their atomic symbols. Now, what is sodium? Na. Potassium is K, copper is Cu, and iron is what? Fe. Alright, so these are what the atomic symbols of what of this particular what element. You get it now? So when you talk about the last one, in simple chemical reactions, radicals remain unchanged during the reaction. Radicals remain what? Unchanged during the chemical reaction. Alright, so let's quickly solve some questions on what balancing of chemical equation. Let's do that now. Question we want to solve now on balancing of chemical equation. So we have to balance the following equation. We have Pb3O4 plus hydrogen gas giving us Pb plus H2O. As we all know, this is the reactant side and this is the product side. So we must ensure that the reactant side is balanced with the what? Product side. If you observe now, we have, let's write out all the what? All the elements. We have let's start with hydrogen. Then followed by oxygen. So here too we have what? Hydrogen followed by oxygen. So now at the reactant side we have 3 lead. Alright, at the product side we have 1 lead. Are you seeing it now? So now at the reactant side we have 2 hydrogen. At the product side we also have what? 2 hydrogen. At the reactant side we have 4 oxygen. At the product side we have just 1 oxygen. Alright, so let's see if the lead is balanced. Now if you observe now, our lead here is 3, our lead here is 1, so it is unbalanced. So how can we balance it? So we have to ensure that we have 3 lead here also, so we can what? This lead can be balanced. So what are you going to do? Multiply this one by 3, so we can have 3 lead. So now, so this is going to be 3 lead, alright? So now we can't say it is balanced yet, okay? Until all the what? All the compounds are what? All balanced. You get it? All the elements are all balanced. You get it now? So now the hydrogen here is 2. So this one is 2 also. So this is balanced. Hydrogen is balanced. So let's see for the oxygen. Oxygen is 4 here. Oxygen is 1 here. So how are we going to balance it? Let's multiply it by 4. So we're going to add 4. Multiply this one by 4. 1 times 4 is 4. Alright, so this is what? 4 oxygen. Are you seeing? So that way I said that we can't say it is balanced yet until we are true. So now we observe now that it has affected our what? Hydrogen. So now hydrogen is how many here now? 8. Hydrogen is 8 here now. I've looked at this now. Hydrogen is how many here? 2. So how are we going to balance it? So we have 2 here. That shows we're going to multiply this by 4. So that we can have what? 8 hydrogen here. 8 hydrogen here. So that will multiply this by 4. So this becomes 8. So this is 4. Are you seeing? So 4 times 2, 8. Are you seeing it now? So this one too. We multiply this by 4 and we have 8. Are you seeing it now? So 4 times 2 is what? 8. So this just, it requires you to use your brain. Do you get it now? So let's see if it is balanced. 3 lead here, 3 lead here. Alright. How many hydrogen? 8 hydrogen. How many hydrogen? 8 hydrogen. Alright. So 8, 8. Oxygen is 4. 4. 4 times 0 oxygen. That 4 times oxygen. This is 4. We multiply this. So this is 4 oxygen. This is also what? 4 oxygen. So this is balanced. So now let's do this one now. Same way we did the first one. Okay. So now let's write out all the what? All the elements. Hydrogen. We have chlorine. We have calcium. And we have carbon. And we have oxygen. So we are going to do the same thing here. Alright. This is the reactant side. This is the product side. So we have hydrogen here. Chlorine. Calcium, carbon, and what? Oxygen. Alright, so now let's check it out now. How many hydrogen do we have here? We have 1 hydrogen here, we have 2 hydrogen here. Are you seeing it? So it is not balanced. What are we going to do? We're going to multiply this by what? We multiply this by 2. So let's say we have 1 hydrogen here, we have what? 2 hydrogen here. 1 hydrogen, 2 hydrogen. So this is what? 1 hydrogen, this is 2 hydrogen. So it is not balanced. So we multiply this by 2. So this becomes 2 hydrogen. Alright, so as I've seen it now, it's going to affect the chlorine. Okay, so this hydrogen is balanced for now. For now. So now our chlorine, we have 2 chlorine here. We have 2 chlorine here. Alright, so let's write that out. Chlorine is balanced, hydrogen is balanced for now. So let's see now, calcium. We have how many calcium here? We have 1 calcium, 1 calcium. Alright, 1 calcium, 1 calcium. So now let's see for carbon. How many carbon do we have? At the reactant side, we have 1 carbon. Alright, at the product side, we also have one carbon, so that is also balanced. Okay, so we are moving to the what? Oxygen. So we have 3 oxygen here at the reactant side. We have 1 oxygen plus 2 oxygen. That makes it what? 3 oxygen. Wow, that shows our equation is balanced. Okay, all this requires you using your brain. Okay, just know how to mathematics. This requires mathematics. If you understand mathematics, then this won't be a problem. Alright, we see it now. All our equation is balanced. You get it now? So 2 hydrogen, 2 hydrogen. This is 2 chlorine. These 2 will, but these 2 will multiply these 2 elements to affect this hydrogen and the chlorine. So this 2 chlorine, this is 2 chlorine. Okay. So this is 1 calcium. This is 1 calcium. 1 carbon, 1 carbon. 3 oxygen. This is 1 oxygen plus 2 oxygen. That makes it 3. So our equation is balanced. So let's solve another one now. Another simple question now. So consider the reaction represented by the following equation below. So we have C2H2 plus YH2 giving us C2H6. So we have to find the value of Y in this equation. So we are given the options. One of these options is the correct answer. Alright, so let's do this now. So we have 2 carbon here. Solution C2H2 plus H2 giving us C2H6. So we have to look for the Y. We have to look for the Y. So I'm not writing the Y, so let me just leave it like that. So we have 2 carbon here, we have 2 carbon here. So we have 2 plus 2. 2 carbon, 2 carbon, 2 plus 2 hydrogen, this is 4. Our hydrogen here is what? 6. How are we going to balance it? You see that it's not balanced. So we have 2 carbon here, 2 carbon here. So what we after is the Y here, okay? So now what is that number that when we add here, we are going to be getting what? 6 hydrogen. Let's think. So now we have all these options here. So we are going with, let's go with 2 first. So now let's see it's going to go 2 times 2 is 4. 4 plus 2 is 6. That shows we also have a 6 hydrogen. That shows that 2 can make this equation to be balanced. So we are going to just add 2 here. So have you seen it now? So we have 6 hydrogen here. Okay, so this equation is balanced. As I've said earlier, all you need to do is just be able to think. Okay, so our Y is what? 2. Very simple. So now let's move to stoichiometry. So this is stoichiometry now. So this is the aspect which deals with quantities of substance. The aspect which deals with quantity of substance is what stoichiometry means. So this deals with the relationship between the amount of the reactants and the products in terms of the mole ratio and mass ratio of the reactants and products. Okay, so this deals with the relationship between the amount of the reactants. Okay, so once you understand balancing of chemical equation, stoichiometry won't be difficult. All right, so that's why we did balancing of chemical equation before we are doing this. Before doing this, okay. So now the what? The relationship between the amount of the reactant and the product in terms of mole ratio. So let's, for instance, say we have HCl plus NaOH giving us NaCl plus H2O. Alright, so when we talk about mole ratio, talk about what the coefficient before the formulae. Alright, so this one, the coefficient of this formulae is 1. There's no number, so it is 1. Okay, this is the mole ratio. So now the mole ratio of what? Sodium hydroxide is 1. Of this one is also 1. Of this one is also 1. If for instance we have 2 here, so the mole ratio is going to be what? 2. Alright, so that's what mole ratio means. Alright, so now when we start solving questions, you're going to understand better. So now let's solve some questions. So they say calculate the mass of lead which would be obtained by eating 42.75 grams of trilead tetraoxide, which is Pb3O4, in a stream of hydrogen gas and the mass of water, H2O, formed at the same time. Alright, so now let's quickly write out the equation now. So most times you will be given the equation, so you have to be the one to write out the equation. So here we have to write out the equation. So we are starting with what? Trilead tetraoxide, which is Pb3O4. So if you look at it, it says calculate the mass which will be obtained by eating 42.75 grams of trilead tetraoxide in a stream of hydrogen gas. Alright, and the mass of water formed. and the mass of water formed. So in a stream of hydrogen gas, are you seeing it now? So when we have something like this, that will give us what? Lead and what? Water. If you observe now, they said what? And the mass of water formed at the same time. So water was what? Formed. Okay, so now let's balance this equation. We have 3 lead here, we have 1 lead here. How are we going to balance it? So we are going to add 3 here. We have 4 hydrogen, we have 4 oxygen, we have 4 oxygen here, we have what? 1 oxygen here. How are we going to balance it? We just add 4 here. Are you seeing it now? So we have what? 8 hydrogen, 2 hydrogen. So let's balance it. We are going to add 4 here again. So if you look at this now, it is balanced. 3 lead, 4 oxygen, 4 oxygen, 8 hydrogen, 4 times 2, 8, 4 times 2, 8. Are you seeing it now? So that's why you must have the knowledge of balancing of chemical equation before you can say you want to start solving questions stoichiometry. Okay, so now if you see it now, we just apply what? Balancing of chemical equation. So calculate the mass of lead, okay, which will be obtained by heating 42.75 gram of Bb3O4 in a stream of hydrogen gas and the mass of water. So we are going to be looking for two formulae here. So we are going to be looking for lead, the mass of lead and the mass of water. Alright, so let's first look for the mass of lead. Okay, so now first and foremost, just what are we looking for? The mass of lead. Alright, by heating 42.75 gram. So what we will be after right now is this one and this one. So for now, let's focus on this and this, because when you eat this one, what are you going to get? You are going to be getting what amount of mass when you eat this one, or when you eat 42.75 gram of this. So let's focus on this and this first. Okay, so we want to get this. So to get this, we focus on this first before we can get that of water. So now let's start with the ratio. So now the ratio of trilead tetroxide, which is this one, is 1. So there's 1 here. So the ratio is 1. The ratio of lead is what? Is 3. Are you seeing it now? So that means that 1 mole of what? Trilead tetroxide will give us what? 3 moles of lead. 1 mole of Bb3O4 gives us 3 mole of lead, which is Pb. Are you seeing it now? So now we're going to find the molar mass of this. Alright, so let's find the molar mass of this and the molar mass of this. Okay, so now let's do that now. So now to find the molar mass of this, we are given Bb to be what? 203. So now the mole ratio will be outside. So what is Pb? Is 207. We multiply by this 3 here, plus oxygen is what? 16. You multiply by this 4. Alright, so when we multiply, what are we going to get? We're going to getting 685. So that will be 685 gram, okay, of what? Pb3O4. So now let's find the molar mass of what? Lead. So lead has what? 3. So we are going to write the 3 here. So lead is what? 207. So that shows we are going to multiply what? 3 by 207. So when we multiply, what are we going to get? We are going to be getting 621 gram of what? Of lead. Are you seeing it now? So 685 gram of Pb3O4 will give us what? 621 gram of lead. So now let's now find lead now. 685 gram of lead. So 685 gram of lead. So 685 gram of lead gives us what? 621 gram of. Alright, so 685 gram of Pb3O4 gives us 621 gram of what? Of lead. So now say that what? Calculate the mass of lead, which will be obtained by heating 42.75 gram of Pb3O4. So that will be what? 42.75 gram of Pb3O4 will give us what? How many mass of lead is unknown. So what are you going to do? We are going to cross multiply. So this will multiply this will multiply this. So that will be 685 times x equals to this multiply this 42.75 times 621. Alright, so divide both sides by the coefficient of x, which is 685. 685. Alright, is what? 38.76. So 38.76 gram of lead. Alright, so the mass of lead will be what? 38.76 gram. So this is the first question. So we want to get the mass of water now. So now let's solve that now. Alright, so we want to get the mass of what? Water. So we've already gotten the molar mass of what? Pp3O4. Now I want to get the molar mass of what? Water now. Alright, so our focus is on what? This and this. The first focus was on this and lead. So we're looking for water now. So to get water, we have to get the molar mass of Pb3O4, which we've gotten already at 685 gram. Okay, so now I want to get the molar mass of water. Alright, so to get the molar mass of water, that would be this 4. The mole ratio of what? Water is 4. Okay, so now hydrogen is 1 times 2 plus oxygen is what? 16. Alright, so now when you calculate this now, you get what? 72 gram of water. Now said by eating 42.75 gram of what? Pb3O4. So that will be what? 42.75 gram of Pb3O4. So what is our water? Alright, which is unknown. So we are going to cross multiply. This will multiply this. 685 times x equals to this multiply this, which is 42.75 times 72. Alright, so divide both sides by the coefficient of x, which is 685. Alright, so our x is equals to 4.49 gram of water, which is H2O. Alright, so when you do the calculation, you'll be getting 4.49 gram of water. Alright, so this is very simple. Okay, so let's solve another question now. So one volume of oxygen measured at XTP, standard temperature pressure. Alright, so now the constant value of the volume at XTP is what? 22.4 dm3. Alright, so the volume at XTP is what? 22.4 dm3. So note that, put it. So now the volume of oxygen measured at XTP will be produced on eating 18.5 gram of nickel 3 oxide. So what is that volume of what? Of oxygen, okay, which is measured at XTP. Okay, so that is what we're looking for now. So now if you see that they say on eating 18.5 gram of nickel 3 oxide, which is NiO2, okay, and what? Oxygen gas. This is what we're looking for. So what we're after now is what? This 2 is what we're after. So we don't need this. Okay, so now what's the mole ratio of what? Nickel 3 oxide? This is 2. The coefficient of what? This formula, which is nickel 3 oxide, is 2. The mole ratio of oxygen is what? Is 3. Alright, so now let's find what? The molar mass of nickel 3 oxide. And they said that what? The volume of what? Oxygen at XTP is 22.4 dm3. So instead of finding the molar mass of oxygen gas, we are going to be using what? The volume of what? The oxygen gas at XTP, which is 22.4. Alright, so now let's do that now. So let's find the molar mass. Our nickel Ni is 58.7. As you see, the mole ratio is 2, so don't forget that. Oxygen is what? 16 times 2. So when you calculate this, you'll be getting 8 gram of nickel 3 oxide. Alright, so now we should be giving us 3 mole ratio of oxygen gas times 22.4 dm3. So that will be giving us 0.2 dm3 of oxygen. Alright, of oxygen. Are you seeing it now? So now said on eating 18.5 gram of nickel 3 oxide. Okay, so that will be 18.5 gram of nickel 3 oxide will give us how many oxygen gas? Are you seeing it now? So what I'm going to do, I'm going to cross multiply. So this will multiply this, so that will be 330.8 times x, 67.2 times 18.5. So we're going to divide both sides by 330.8, which is the coefficient of x. This one to 330.8. This cancel this. 3.76 dm3 of oxygen gas, 6 dm cube of oxygen gas. Are you seeing it? Well, it's very simple. So it is very simple. If you have any question, do well to use the comment section below. So now let's solve another question presented below. So we are given the equation here now. So we are not the ones that will be looking for the equation. So this is the equation that as we can see, we have to calculate the volume of what hydrochloric acid, okay, that can be what obtained at XTP. Again, are you seeing it at XTP from 5.85 gram of sodium chloride? Okay, so we are given the relative molecular mass. All right. So now let's do that now. So our focus will be what and what the sodium chloride that was mentioned and what the HCl. All right, hydrochloric gas. All right. So that is what this will be our focus. Just these two compounds. Okay. So what is the mole ratio first and foremost? So we have 2 here. We also have 2 here. The mole ratio is important too, so don't neglect the mole ratio. So now we said calculate the volume of what hydrochloric gas that can be obtained at XTP. At XTP, all right. So now when we have what from 5.85 gram of sodium chloride. So let's find the molar mass of sodium chloride. So our sodium is given as 23. So this is 2 now. The mole ratio is 2. Sodium is what 23. Chlorine is 35.5. Okay. So now when you calculate it, you get 117. So that will be 117 gram of sodium chloride. So now if you remember, they said what? At XTP, okay? The volume of HCl that can be obtained at XTP, and I told you that what XTP is what constant is what 22.4 dm cube. The volume of what? The volume of HCl gas at XTP is always 22.4 dm cube. That will be 2, which is this 2 times 22.4 dm cube. Alright? So that will be giving us what? This is 44.8 dm cube. 44.8 dm cube of hydrochloric gas. So now I now said what? That can be obtained at XTP from 5.85 gram of sodium chloride. That will be 5.85 gram of sodium chloride. So we are looking for the HCl now at what? On eating 5.85 gram of sodium chloride, and this is X or no. Okay, so we are going to cross multiply. All right, so now let's see, let's cross multiply. So this will multiply this, that will be 117 times X equals to this multiply this, that is 44.8 times 5.85. all right, so we are going to divide both sides by 117. All right, so when you cancel this, so our X is equals to 2.24 dm cube of hydrochloric gas. All right, 2.24. all right, so that is our answer. Are you seeing it now? So it's as simple as ABC. So those who watch this video to the very end, thank you so much. If you're joining our platform for the first time and you benefit from this video, please do well to click on the subscribe button, for it does not bite. Thanks so much, and thanks for watching this video to this period. God bless you. Bye.